That's how the video started, Riley. And I didn't even not hit record. It's recording right now. Okay, completing the square. With completing the square, your goal is to go from standard to vertex form. So that's like the whole goal. You're given standard, which is a, b, c, like a squared plus bx plus c. And the vertex is, x minus h squared plus k. So in order to do that, the first step is you move your constant over to the other side. So I'm going to say x squared plus 10x plus blank equals negative 21. And you have a blank there because what you're trying to do is you're trying to make that a perfect square. So you need to fill in like what constant is going to make that a perfect square. The constant that you put in is half of the middle term squared. 25. Good. Whatever you add to the left, you also have to add to the right to make it a balanced equation. The x minus h squared plus k. And so to factor this, it's x plus 5 squared equals 4. I normally just do it all in one step where I put minus 4 equals 0. Like so. So try 6, 7, and 8 now that you have that knowledge. Okay, so here are all the answers. Did everybody get those? We're good. Okay, let's move on to 10.1. So here are the 4 conic sections that we are going to talk about. We have circle. I'm just going to highlight. This is all part of double cone. A circle, a parabola, an ellipse, and a hyperbola. And these are the different shapes that are made when you make different cross sections into a cone, essentially. I know, you thought we were done. So today we're going to learn how to identify them, and then we're also going to learn how to put them into what we call vertex form. So we're not going to do any graphing today. We're just going to learn like looking at an equation and identifying which of the 4 it is, and then completing the square to get them into their vertex form.
So it's basically just like finding each of them on a graphing plane?
Right. So every single conic looks like this in standard or general form.
Conic just means it's part of a cone, right?
Like the cross section of a cone. So if you took a piece of paper, like if I had a cone sitting here on my table, imagine that this coffee cup is a cone. And I took a piece of paper, I'm going to take this packet, and I crossed it or I cut into it. Depending on if I went flat, that would make a circle. If I came at an angle, then it could make a parabola. If I went up a little higher and went at an angle, it'd be an ellipse. And then if I went vertically, that would make a hyperbola. So just kind of looking at it visually. No, you don't have to memorize the pictures, but I'm going to tell you like how to identify what conic it is based on just looking at the equation. So when your A value equals your C, so we're looking just at the coefficients in front. So here's my A x squared, and here's my C y squared, because each equation now will have an x and a y. If they have the same coefficient in front, like A equals C, then we call that a circle. If A and C have different signs, so like one is positive and one is negative, we call that a hyperbola. So A times C is less than 0. If A and C have the same sign but different numbers, we call that an ellipse. They have to be the same numbers for a circle. For a hyperbola, they can have different signs and different numbers. Or the same numbers. Like, it doesn't have to be, it can be same or different numbers. But just knowing that they have different signs is what tells you that it's a hyperbola. An ellipse is when they have same sign, different number. And if you only have one or the other, so like one or the other, like you only have an x squared or a y squared, but you don't have both of them, then that's a parabola. So we are going to graph y squared parabolas now, which means they go sideways. They're kind of cool. So I'm going to write out the vertex form for you guys underneath. So this is kind of like what the goal is of what you're trying, when you're completing the square. This is like the form that you're trying to get it into. You will be given these formulas. I will never make you memorize them. So for a circle, we have, and kind of start out to the left so that you have enough room, x minus h squared plus y minus k squared equals r squared. We will, yeah, there'll be numbers. For right now, this is like the vertex form. We'll deal with numbers once we get to each individual section. For a hyperbola, we have x minus h squared over a squared minus y minus k squared over b squared equals 1. No, I just said we don't have to memorize them. For an ellipse, x minus h squared over a squared plus y minus k squared over b squared equals 1. So far, the difference we see is minus and plus. And then a parabola, you will have, there's two options. You could have y equals a x minus h squared plus k. Yeah, this is the one that we've always seen. One that's different is you could have x equals a y minus k squared plus h. It's kind of weird. So one of the two. Now, we're not going to be doing anything weird with them today. Like, we're going to take each section in this chapter is like zeroing in on each one of these conic sections. Today, we're just looking at the big picture and identifying them and then trying to complete the square to get it in this standard form, or in this vertex form, excuse me. So like I said, you don't have to memorize these. They will be given to you. Just have them here so that we can go back and refer to them throughout the rest of the section. So first step is I want to identify what my A and my C are. The A is always the number in front of the x squared. The C is always the number in front of the y squared. So here I've got A and C. I'm going to use a different color. So here's my A, here's my C. What do we know about these two? They're different signs, so that makes it a hyperbola. Good. Okay, now we're going to complete the square to get it into the vertex form. So looking back and referring back to it, I'm going to take you kind of through the steps of how to do that. And we're going to get lots of practice with this, so if you don't exactly get it today, that is okay. So your first step when you're completing the square with two variables, so now we have an x and we have a y, you're going to get all of your x's together and all of your y's together. So I'm going to rewrite this as x squared plus 4x minus 4y squared minus 8y equals negative 16. So what I did is I put my x's together, I put my y's together, and I moved my constant to the right side. So just organizing yourself first is your first step. Now you're going to complete the square twice. Once for the y's and once for the x's. The only trick is when you complete the square, the number in front of the squared has to be 1. So with my x's, I don't have any issue. So x squared plus 4x plus blank. Now, for the y's, I do have a coefficient in front. It's negative 4. So I need to pull the negative 4 out and then write what I have left over. So y squared, then what would be next? If I pull a negative 4 out of this negative 8, what happens? Plus 2y plus blank equals, kind of running out of room, sorry, negative 16 plus blank plus blank. I've got 2 blanks now. Okay, from here, what is going to go in my x blank? 4, because I take half of 4 and then square it, becomes 4 here, 4 here. What number is going to go in my y blank? 1. So you put a 1 here. Okay, this is the hardest part, so I want everyone to put your pencil down and look at this. I need to figure out, like, this is the equivalent of killing puppies in this chapter. I think I'm going to get a new meme up here. You do not put a 1 in the second blank. You take the negative 4 times the 1, and you put a negative 4 here. Okay? This is the equivalent of killing puppies. You must multiply the number in front and then put it in the last blank. Going to get a new tally going. So if you put a 1 right here, you've killed a puppy. Okay, now I factor. So x plus 2 squared minus 4y plus 1 squared equals what? Negative 16. Good. Now, what is something that you notice going back to the original the original equation that you wrote down at the top? What is it equal to? What is a hyperbola equal to? 0. Equals 1. Like, what was on the right-hand side of the equation? 1, right? So, in a hyperbola and an ellipse, you always want to set them equal to 1. So what do I need to divide by to get this right side to equal 1? Negative 16. So I'm going to divide everything by negative 16. This side, this side. So imagine, and this might be easier for me to write it this way, imagine taking this over negative 16 and this over negative 16. So the right-hand side cancels to become 1. My final answer is x plus 2 squared negative 16. What happens to the negative 4 and the negative 16? Cancels and becomes just a 4 on the bottom. So plus y plus 1 squared over 4. Well, so what happens in a hyperbola is it is a minus, but you could switch the x and the y, and you could write it like where the y is first, minus x plus 2 squared over 16 equals 1.
But it's not the same thing that you gave us in our form.
Whenever we get to that section, I'll show you that you can either have the x or the y first, and that determines whether it's a vertical or horizontal hyperbola. I didn't want to stress you out too much. It does not matter if the x or the y is first in a hyperbola.
Go with whatever the sign is.
Yes.
I'm confused on the, like when you divide the negative 16, like just can't do that plus.
Because you're wanting to match it to the original equation that we wrote at the top. You want to have a 1. You don't want to have a 0 on the right side. You want to have a 1. So just know that when you get to this point, you're always going to divide by whatever's on the right-hand side. So this is my final answer right here. Okay, so let's first identify number 2, and then I'm going to let you try completing the square on your own. So I'm going to circle my A and my C, number in front, number in front. What do we notice about them? They're the same. So then that means that it is a circle. Good. Now I'm going to rewrite this. Put my x squareds together. Equals 21. Now I want you to try completing the square from here. You're going to do it twice. And then what also do we have to do for each one? Since the value in front of the x and the y squareds are not 1, we have to pull out a what? Pull out a 3 from both of them. So the vertex form of a circle, you can't have any coefficients in front of the parentheses. So your last step is always to divide by those. So in an ellipse and a hyperbola, the last step is to divide by the right-hand side to get it equal to 1. In a circle, the last step is to divide by the coefficients in front of your parentheses, because you can have a number on the right here. So questions about number 2? All right, let's go to the next. Okay, so number 3, right now they look like they're different signs, but you have to put them on the same side of the equation first. So let's rewrite this to where we're about to complete the square, then we can identify. Okay, so I'm going to rewrite this.
Thornhill?
Yes. Okay, so I'm going to rewrite this. I'm going to put the x squareds first. So 2x squared minus 8x plus 5y squared plus 10y equals 37. So all I did is I moved the x's over and then kept the y's, put the constants on the right. From here, what do I notice about the signs in front of the x squared and the y squared? Same sign, but they're different numbers, so that means that it is an ellipse. Okay, so try completing the square. We're looking at the x's, looking at the y's, pull out the 2 and pull out the 5. But remember, when you're adding it to the right, you don't want to kill a puppy, so you multiply it by the 2, multiply it by the 5. Okay, questions about number 3? We okay with this? And we're going to get practice with this with every section, so it does not go away. This is, I think, one of the hardest parts of the unit. So we start it early so that you get lots of practice. You'll be pros at it. Okay, looking at number 4, we could rewrite this where put the x's first and then the y's But what do you notice is that there's only one of the two. There's no x squared. So that means that it is a parabola. Now, when you have a parabola, something interesting about a parabola is when you have a parabola, you want to move the x over and the number. Or like you want to move the single term over and you want the constant. So you want them both on the other side and you only want to keep the squared term on the left. So I'm going to rewrite this as 5y squared minus 10y equals 15x plus 25. Okay, from there, I want to complete the square. So 5y squared minus 2y plus 1 equals 15x plus 25 plus what? Plus 5.
Why does the 10 say it's not squared?
Because that's what you use to complete the square with. Because they both have a y.
So if only an x was here, then we would remove the y term.
Now I'm going to factor, so I've got 5 y minus 1 squared equals 15. Nope, I'm going to keep that, hold on, 15x plus 30. Now, looking at the original, if you go back to what, remember we wrote 2 of them. If this was an x equals equation, the one that we're trying to match is x equals a y minus k squared plus h, right? So if I want to get x by itself here, like an x equals, what would I need to do? Subtract 30 and then divide by 15. So if I subtract 30, I like this being on the left-hand side. I don't know, I'm just weird about that. So I'm going to rewrite this like this. Now I'm going to subtract 30. So 15x equals 5, y minus 1 squared minus 30. And then I'm going to divide by 15. And you have to do it to all parts. So x equals 5 over 15 is what? Just 1/3. Y minus 1 squared. Then what? 30 over 15 reduces to 2. So once you get to the point of completing the square, it's kind of like a puzzle. Like, how do I make this match my original? Because from there I'm going to ask you questions. So in this case, I could say, what's the vertex? Well, if the vertex is HK, then your vertex would be at 2, 1. Or negative 2, 1, sorry. We haven't gotten to that point yet. I'm just going to, don't worry about that. I'm just saying I will ask you questions about it. So you want to get it to match the original so that you're able to answer questions about it. Yes?
So if you put it y minus 1 squared equal to 3, that would be wrong.
No, that wouldn't be wrong. But if I said what's the a value, you would need to know that it's 1/3. So saying this over 3 is the same thing. But when you put the 1/3 out in front, it kind of helps you to identify the a value. Okay, same kind of thing here. I want to get everything to one side. 2x squared plus 16x plus 2y squared minus 8y equals negative 25. So what do we notice about this one? Same a value, which indicates it is a circle. circle. And I'm going to go ahead and we're going to move to number 6 because I'm going to have you guys complete the square. I just want to go over identifying it. We've got x squared minus 2x minus y squared plus 4y equals 12. So I just wanted to keep this, and I moved these two over. What do you notice about the signs here? They're different, so that means it's a hyperbola. Okay, so I want you to complete the square for both of these, and then we will be done. Okay, so on the circle, don't forget that you can't have any coefficients in front of the x squared and the y squared. So you divide, they'll always be the same number, so you always divide by that number. It's okay if you get a fraction. And then on the hyperbola, I pulled out a -1, so remember you pull out the negative no matter what. Divide everything by the stuff on the right. So I divided by the 9.